Welcome, everyone. I'm very pleased to be hosting this virtual open day for the MSc in Smart Buildings and Digital Engineering. I'm Dr. Valentina Marincioni, and I'm the lecturer, one of the lecturers in the program, and I'm also the program director. I'm a lecturer in building physics, and today we're also joined by Dr. Rui Tang, who is a deputy director and lecturer in Smart Buildings and Digital Engineering, who is going to give us a taster lecture on machine learning in smart buildings. After the lecture, we will have time for a Q&A session. So please, I would like to encourage you to write your questions in the Q&A function of Zoom. You can ask us questions about the taster lecture, but you can ask also questions about the program as a whole and any other curiosities you might have. So I'll be there with you after the lecture of Rui. So the session will be recorded and the recordings will be shared with attendees. So I leave the floor to Rui for this taster lecture, and I'll be with you at the end of the lecture.
Good morning, good afternoon, even good evening to everyone, depending on where you are now. So my name is Rui Tang, a lecturer in smart buildings and digital engineering, and also I'm serving as a deputy director for this MSc program. So I'm also the module lead for one co-module for this MSc program, machine learning in smart buildings. And today's taster lecture, I will give you a sense so what you can learn from this co-module. So next slide, please. Thank you. So in this taste lecture, I will cover 4 points. The first one is, so why smart building is very important. And the second one is, so why we need to link machine learning with smart buildings. And also I will introduce how I structured this module to deliver the knowledge and introduce machine learning techniques in the context of smart buildings. And the last one, I will give you an example of application using machine learning in smart buildings to give you concrete examples. So next slide, please. So regarding the first one, so why smart buildings are very important and worth of our time and effort in this domain. So if you see the picture in the left corner, so we can see almost everywhere across the world in the past decades experienced temperature increase. We are facing global warming and climate change. A lot of countries now in the world has made commitment to being carbon neutral by certain time. For example, the UK has already made commitment to being carbon neutral by 2050. China, one of the biggest country and also the second largest economy in the world, also set its own goal to realize carbon neutrality by 2060. So this is about the context of energy crisis and climate change. So next slide, please. So within this context, what's the roles of building sectors played? If you see the left-hand figure, over 1/3 of energy were used by building sectors in 2020. And if you see the carbon emissions, so we can see around 28% of carbon dioxide were produced by building sector in 2020. So based on these two figures, we can get the conclusion that building is one of the largest energy user and carbon emitter around the world. Next slide, please. So now we know how important of buildings in the context of energy efficiency, sustainability, even say carbon neutrality. So what's the current situation of developing smart buildings? So compare with buildings, for example, 10 years ago. Now modern building is more complicated. Why? There are two reasons. So the first one is, so you know, the living standard is increasing all the time. So occupants in the building expect a higher standard of living environment. The second reason is because if we go beyond the physical boundary of buildings, Now we want to use more and more renewable energy systems. So in the future, the energy system, even say low carbon energy system, is expected to be highly connected. So building need to coordinate with other sectors of energy system. So these different sectors of energy system will make the smart building development more complicated. So next slide, please. Now this is about story of smart buildings. So if we move to the machine learning domain, if you see the left-hand side figure, over 90% of data were generated in the past 2-3 years. So if you see the right-hand side, more examples on this huge amount of data. For example, for Google, every minute, nearly 5 million data could be generated. So building sector is not an exception. Huge amount of data now are available in domain of buildings. So, but raw data itself is meaningless. How to convert this raw data into meaningful information and insight is very important. So we need more advanced technology to deal with this challenge. So next slide, please. So here are some examples about using machine learning techniques to solve our real-life problems. For example, the face recognition technology. So I think everyone here use this technology every day. So for example, when you log into your mobile phone, log into your bank account, so you are experiencing this technology, even though you are not realizing it. For example, for the Amazon, so when you walk through the Amazon website, there are lots of recommendations for you. So this one, there's a machine learning algorithm behind to provide these recommendations based on your past experience. So next slide, please. Here are two more examples using machine learning technologies. So one example is the left-hand side is about AlphaGo. I think everyone here heard this news before. So around 7-8 years ago, DeepMind developed AlphaGo. So AlphaGo won the world champion of GameGo. So this example was not very far away from us because DeepMind was founded by UCL Department of Computer Science. So around 3 years later, so OpenAI develop algorithm to let computer to play a more complicated game, Dota. So if you see the right-hand side figure, so this this technology can let computer to learn by itself to develop its own algorithm and rules, and this algorithm and rules can win the world champion on this game. So now there are a lot of stories about a successful application using machine learning technologies, even more broadly artificial intelligence. So now just a brief summary about these two branches, smart buildings and machine learning. So in smart buildings, we are facing more and more challenges, and the system itself is more complicated increasingly. For the other branch of machine learning, everyone nowadays realize the power of machine learning technologies. So now the conclusion is, so why not combine these two branches together and apply machine learning technologies to solve the challenges in the domain of smart buildings. So next slide, please. So based on this, we come to this core module within this MSc program. So within this module, we will introduce machine learning techniques in the context of smart buildings and describe some of core algorithms and to introduce the machine learning technologies. So we expect you after this module, so you can develop your own machine learning model and apply them to solve the problems in the area of smart buildings and also support, for example, building design and operation. The second expectation for this module is we hope after this module, so you can identify the most suitable algorithms by yourself to solve a particular problems in the domain of smart buildings. Also, I hope you can understand the role and the limitations of machine learning techniques and the data-driven models. So facing on the problems you are working on. So last one is we also through this course, so you will develop your own hands-on experience in applying machine learning technologies into the domain of smart buildings. So through this process, you can grasp some skills in coding using Python. And next slide, please. So this slide basically is to introduce how this module is structured. So we have five parts in this module. The first part is about machine learning fundamentals. Later, I will give you an example about what these machine learning fundamentals will cover in this module. Part 2, 3, 4. So these three parts are basically based on the categorization of machine learning technologies, supervised learning, unsupervised learning, and reinforcement learning. So we also have practical applications. So these practical applications are more referring to the in-class tutorial. So we will give you corresponding case studies based on what we have introduced in the class to consolidate and strengthen your knowledge and skills learned in the class. So throughout the module, we will also invite guest lectures to introduce some cutting-edge research works. So in this case, I think it could be very helpful for you to link the in-class knowledge and skills with the cutting-edge research work to give you more idea. So what could be the current challenges and the questions we are facing in the domain of machine learning and smart buildings. So next slide, please. Within this module, so basically we will use this slide give you an idea. So what kind of software and the Python libraries you will use throughout this module. So here we will use a Python Jupyter Notebook as the platform to implement your Python code and the different libraries based on your different needs. So next slide, please. This module is 10 weeks teaching. So basically within 1 week, we have 3 hours teaching. Half of these 3 hours will go for lecture. The other half will go for tutorial. So again, this tutorial is case study based. So we will tutorial is designed based on the lecture. So we will provide concrete examples and case studies to contextualize the knowledge, algorithms you learned in the lecture. Within each week, we also have a drop-in session around 1 hour per week. So basically, within this drop-in session, you can ask your own questions and get the right answer from us. 10 weeks teaching, 3 hours each week. In total, we have 30 hours for this module. So machine learning, is a very broad area. These 30 hours is totally not enough to cover everything. So in this case, we also provide some recommended reading materials based on the topic we introduced at that week. We also use a Moodle page. So Moodle page is an online platform. So you can post your own questions or queries whenever you want, and we will reply your questions and queries as soon as possible. The last part is the coursework. So for this coursework, it's not only about assess the performance of your learning, but also this is a good chance to contextualize the knowledge skills you learned from this module. The data will be given to you, and you have enough flexibility to design your own task. So basically, within this coursework, you have 3 subtasks based on the categorization of machine learning domain. Supervised learning, subtask 1, unsupervised learning, subtask 2, reinforcement learning is the last subtask 3. Next slide, please. So now is the last part of this test lecture. So I will give you some examples on this module. So basically, it's more about the link between machine learning and the smart buildings. So if you remember what I just mentioned, the first part of this module is about the introduction of machine learning fundamentals. This is one example. Now, I think most of you have already heard a lot of buzzwords, for example, artificial intelligence, machine learning, deep learning, so even beyond. One objective of these machine learning fundamentals, so we will cover the basic definitions, concept, within the domain of machine learning to help you comb through the logic of the whole machine learning picture. So for example, in this case, we will introduce the link and the relationship between deep learning, machine learning, artificial intelligence. Next slide, please. So this is about what we will cover within the first part of machine learning fundamentals. And the next three parts are introduced based on the categorization of machine learning techniques. So because of the time, I cannot give every example corresponding to each categories. But in this case, I just pick up reinforcement learning as an example. So how to and what could be the potential using reinforcement learning to revolutionize the domain of smart building. This slide shows the basic mechanism how this reinforcement learning works. I won't cover very detailed mechanism on these algorithms because of the time. But within this module, we will introduce how this algorithm is working, and also we will give you a example and how this algorithm can be functioning very well. In a nutshell, reinforcement learning is based on the interaction between the agent and the environment. So this agent is help human beings to make decision and replace the human being. So in other words, our target is to train an agent and help us to make smart and optimal decisions in this case. So next slide, please. So now it's about concept and the theory of reinforcement learning itself. Now we move into the domain of smart buildings, and we wanna find a proper place to apply this technology. So this slide shows the evolution of building controls in the past decades. So in general, we have three generations of building control technologies: rule-based control, model predictive control, reinforcement learning control. So the first one is rule-based control. So as you know, rule-based control is very simple, and the fact is rule-based control nowadays is widely applied in the real building. So if you see this light blue box, the set points, this is the key of rule-based control. So basically, how these set points are determined. Set points basically are determined by the experts engineering based on their experience. So this process can inevitably introduce bias, and even some of these set points are incorrect. Another big drawback of this rule-based control is we cannot implement optimization process in this process because you need to decide the exact value of these set points before we implement these control strategies in real buildings. And if you look back the background of smart buildings, in the future, the energy system need to be coordinated with each other. So this is if we are saying how to operate buildings. So this is optimization problem. Why? Because we need to coordinate building energy use with other sectors of energy system. So rule-based control is totally incapable to realize this optimization process. So if we wanna develop smart buildings to meet the future needs and challenge, so we need to move into more advanced control method. Now we come into this model predictive control. So model predictive control, basically based on the name, so we can see we need a model to realize this model predictive control. One thing is this model within this method is a place to apply machine learning technologies. But I won't cover this in this test lecture because it's nothing related to reinforcement learning. So because I want to introduce the relationship between reinforcement learning and the smart buildings. But anyway, this model predictive control is a place to apply machine learning techniques. The drawbacks of model predictive control basically are twofold. The first one is, so if you heard a word before, all models are wrong, but sometimes are useful. So when we develop model, you cannot ensure 100% correct of your model, right? So there are lots of bias in accuracy within your model. So this will cause some negative effects on your building control. The second problem is model development process is expertise hungry and time consuming. So for some industry applications, it is very difficult to develop a model to realize this model predictive control. So because of these two reasons, we move into reinforcement learning. So how this reinforcement learning works? So basically, it's through the interaction with the environment. The agent is based on his own experience to develop the control logic. So in other words, reinforcement learning can be model-free. So we don't need to develop a model to realize this method. So in this way, we can avoid the bias in accuracy in the process of model development. Because of no model required, so we can save our time, save our effort. So this is why reinforcement learning is very promising in the application of building controls. So next slide, please. In this module, when we introduce reinforcement learning, so basically this is one example I pick up from the module. So we have the testing platform, and also we have the model on the application of reinforcement learning in building controls. So this figure just give you a sense how this testing process looks like. So basically, in this case, we use our office building. So this office building has one story and with five zones. So we apply reinforcement learning based control method to control the operation of HVAC, heating, ventilation, and air conditioning systems in this office building. And we compare the control performance against the other two methods, rule-based control and the model predictive control, to compare the performance against each other. So next slide, please. So here are more details about the result. So I won't delve into very details on these figures. So very briefly, the targets here, one is thermal comfort. You know, thermal comfort is very important to meet the expectation of occupants in the buildings. The second one is energy consumption, because energy consumption is not only related to energy use, but also related to the carbon emission. On the right corner, the up corner, so you can see there are lots of different curves. So basically, we compare the performance of convergence speed of our reinforcement learning. And the left corner, basically, so one figure is about thermal comfort, the other figure is about energy consumptions using different control method, rule-based control, model predictive control, and reinforcement learning control. So it's a very straightforward way to compare with the control performance using different technologies. So within this module, we will use this way to introduce every algorithm followed by a solid example as a case study to strengthen and consolidate your understanding. And also we will use this one 1.5 hours of tutorial to give you a chance to exercise your hands-on skills in coding, in implementing machine learning algorithms in the domain of smart buildings. So this case just give you a sense how this process looks like. So next slide, please. So now is my this lecture about this core module within the MSc program, machine learning in smart buildings. And if you have any questions, feel free to ask. Thank you again for listening my my talk.
Thank you very much, Rui. So we have some questions already coming up, but please feel free to ask more questions. I can start. Well, there's a question asking if we offer the course as a distance learning option. Unfortunately, we don't. Our program is it's an in-person program. However, if you're based in the UK, we have opportunities for part-time or flexible mode, so you could attend there are different ways of attendance, but we expect in-person attendance. Then there is another question about if it's a requirement for someone to join the MSc to know all about Python from day one. Thank you very much for that question. We are not expecting students to be proficient in Python. The only thing, so we have a drop-in session every week from week one that is aimed at supporting the students in their own learning journey with Python towards the machine learning module. So of course, the machine learning module will require a good understanding of Python, but we have term one, where students are using Python in a simple way and also are supported in using Python with the weekly drop-in session so that they become, so you can become more, we can become up to speed with Python, particularly with the applications that Rui has already mentioned. One point that I would like to mention is that, okay, Python is not a prerequisite, but we highly recommend if you're determined to join us, we highly recommend to take one of these online MOOC, these online courses on Python, which are for free and available. We don't teach Python because we have a lot other, we need to teach other aspects of smart buildings, but that's why we are providing support, weekly support, because you can do your learning in your own time before joining. And again, we are not expecting for you to be proficient. We are expecting you to understand the basic principles and fundamentals of Python. What we normally do, we recommend a couple of online courses, and which I can share in the chat. And then we recommend you to spend, if you're planning to join us at SBD, maybe spend the summer doing some of these simple courses on data analysis, and then we can help you, support you in the development of your Python skills. I hope this is enough. It's clear. So yeah, we don't expect you to be proficient, but we expect some interest and some basic understanding. It's good. It's better for you. Then, so question about the scholarship opportunities. I can share some opportunities on the chat. Not very good at multitasking. Just give me 1 second. Yes, so what are the scholarship opportunities for the program? We have few scholarship opportunities which are open to different students. So we have, for example, the Bartlett Promise UK Master's Scholarship, which is closing on the 31st of May. And that is for UK domiciled students with home fee status, which are from backgrounds which are underrepresented in the Bartlett. So I can share the scholarship with you. Then there is another scholarship called Great Scholarship, and this scholarship is closing fairly soon. So if you think you're eligible, please apply as soon as you can. The scholarship, particularly, it's funded by UCL and the British Council, and it aims to provide financial support to citizens of Bangladesh, India, Malaysia, and Nigeria. So if you are from, if you And then we have one more scholarship, which is called the UCL Global Masters Scholarship. And this aims to enable and encourage international students from lower income backgrounds to pursue a full-time master's degree in the UCL. So I'm going to share again the link with you. So I hope this is an overview of the scholarships that we have available. I hope this is helpful. If there are, okay. Okay, there is a question. Could you please give me some advice on the suitable employment directions for a student who has a background in electrical engineering and experience in smart building design? Thank you. Okay, so in terms of, so what we do at Smart Buildings and Digital Engineering, we have some electrical engineering students who have attended the program, particularly because they wanted to be more exposed to smart buildings as a field. So they come with an electrical engineering background, but they want to understand more the mechanical, the building physics, the building services, mechanical part, and the integrated approach to the design. So those students that are joining and take that that journey, they can become smart building consultants. So we have a number of students who are now working in smart buildings in medium and large consultancies, or you could still work in electrical building services, but with a greater understanding on what the smart building offering is. So it depends on you, really. It depends if you're happy, still interested in electrical engineering, but you want to, be more exposed to the other aspects of smart building design and how everything is put together to develop a smart building offer, then this is one way. So you can still work as an electrical engineer in smart buildings, working on the deployment of the sensors and so on, but with a broader understanding on the integrated approach. Or you could expand and work on the smart building side, so use your skills, apply them to the smart buildings deployment, and also looking at how to gather, what are the processes of gathering the data, what are the processes of using the data, and using those the IoT, which is in development. But also you could move on to the data analysis and facility management. So it's really like the program is not providing one option when you go out. We have students from a number of backgrounds in terms of engineers. We have architects with a technical background. They all use the degree in a different way. They all learn more, and often they bring it back in their area of interest. So I hope this is helpful. We have a list of usual professions that could be applicable, but again, it really depends on your background and on your interest. Okay. Let me check other questions we have. Okay, we have a question for Rui. I'm going to read it. Hi, Rui Tang. I'm Juan Long Liu. I really like your papers. I graduated from UAL with a major interior and spatial design. I would like to know if I choose to do a postgraduate degree in light and lighting, will I have the opportunity to apply for your PhD, to be your PhD student in the future?
So
that's for you, Rui.
So thanks for your questions. And so it depends because each year for every academic staff within IED, so just give you a overall picture. So IED is our institute, and MSc program, Smart Building and Digital Engineering, is one MSc program under the umbrella of IED. So every academic staff within IED, so each year basically has different arrangement in the PhD recruitment based on the work they want to do, based on the funding available. So basically, I think each year the demand, even say the same people, the demand for PhD students is quite different because the topic of each year, even say for the same academic staff, is changing all the time. So it depends. So I cannot say any certain things at this time. But basically, this lighting is another MSc program under the umbrella of IED. So within IED, we have different MSc program. I think there are some interlinks between different MSc programs. So I need to say it could be, but it depends. So I hope I answer your questions.
Yeah, so okay. Yes, again, with the PhD programs, there has to be a conversation, like a separate conversation. And yeah, and it really depends on the funding. It really depends on a number of important points that need to be all met. Sometimes, like what I can say in general about smart buildings and digital engineering is that our students, we always have one or two students in terms of going back to the career prospects. We always have one or two students who go on to do a PhD, which is great for us. So we have, while the majority of students, as we normally expect, they go into the industry. Some students decide to continue and pursue the PhD, and usually they are quite successful in their application. So, and we support students in of course, providing references. And so this is something that we are very pleased about in smart buildings and digital engineering, because our work, while we always make sure that we are relevant for the industry, we also want to make sure that our students become independent researchers. So our dissertation project, it's aimed at developing an independent researcher, and we can see the benefits and the results in our students who are now successful academics and successful professionals as well. So thank you, Dana. Okay. Great. And then, so there are other questions here. Will there be opportunities to take learning outside of the classroom? Yes, of course. We have a number of opportunities for students to be involved in different activities. So we have the classroom, but one point during lecture is also that we have guest lecturers that come from industry or from other parts of academia. So Rui's module, you have, I think every module has, I'm not sure every module, but definitely my module and Rui's module have colleagues from academia and from industry coming and talking about the latest research. but also outside the classroom, we go on a site visit to a smart building every year. We also go to Bath, where we have a look at some application of smart buildings as well as to team buildings, but we do that. Or also we liaise with companies, giving you some example of the companies we've met this year. It's Design Builder, Bureau Happold, Arup, and other companies. So it's there are always opportunities each year. The opportunities change, as in the site visit is not always the same, because we always look for the latest developments, and but we always look for smart buildings in the area, in London and outside London. And but also we have a laboratory day, which we have our labs. I'm in the lab, as you can see. We have our labs, which look at building physics, building services, and other aspects of the built environment. But we also have living labs, like our new building at UCL East. So we have a number of opportunities to take this learning outside of the classroom. We also have encouraged students to be engaged with SIPSI student membership. We encourage students to be engaged with ASHRAE. So we have a number of opportunities. Again, the opportunities really depends also on you, because you might be interested in an area or the other. You might be interested in UK-based learning, or you might be willing to look elsewhere. So we try to encourage opportunities, of course, in and around London and in the UK. And we try to encourage conversations with the industry. But then we also want to hear from you. And a lot of the opportunities also come from discussions with students. So our students are, through our student representatives, we are also organizing activities that could really support your further development. For example, this year this is an example for this year, which came from the students. So we did a grasshopper session, and this is just an example of what can happen from a conversation with the students. Okay, do we have any other questions? Okay. So we have one more question. Alongside learning Python, what other subjects do you recommend learning over the summer period to prepare for the course? So normally we recommend getting up to speed with Python. So that's the most important for us. And then, of course, if you're like, you might be interested in reading about smart buildings already, but in terms of skills and knowledge development, I think, yeah, if something really, if you want to prioritize something, really the priority should be learning basic skills in Python and data analysis. I think that would be very beneficial for you, because you wouldn't have to learn that during term time, and you can concentrate on learning about smart buildings. So I think we don't want to recommend too much around preparing for next year, but I think my recommendation, and I don't know if Rui, you have other additional recommendation, but my recommendation is get up to speed with Python, which is a tool that we are going to use from day one until your dissertation and further. And what I can also add, we had a recent career event for SBD students, and one of our alumni mentioned that one of the most precious areas of skill development was actually Python for him, who is a sustainability consultant now. because he can really use Python across the in his work, and so yes. So I just want to mention, it's not just me saying learn Python. Probably Rui would say the same, but also the alumni think it's
yeah. So yeah, might say something on this one. So yeah, I totally agree with Valentina. So in addition to Python, basically, because I don't know your background, educational background. So whether you're from, for example, electrical engineering, building services. So it depends. So because our program, the name is Smart Buildings and the Digital Engineering. So if you come from a different discipline area, so I suggest you to learn some basic knowledge within the area of smart building. So basically, I think it could be very helpful for you speed up the learning journey within this 1 year MSc study. But if you come from the domain of smart buildings, so that means you already have the knowledge, skills about smart buildings. So in this case, so you can pursue like Python, even other modeling techniques, so more advanced skills and technology. So I think it depends on your background, depends on to which level you can grasp the knowledge and skills in the area of smart buildings. Yeah, so I hope it helped.
Thank you. So I'm actually, in the meantime, I'm answering a question. There was a question about the 2-year part-time program, and I've shared the link to the SPD website. Towards the end of it, under teaching and learning, there is a bit more information on what a part-time and what a flexible program is. And I recommend also emailing me we can have a separate meeting, because it's in terms of flexible students and part-time students, the best way is to have a conversation and really have a look at what are the opportunities. So what I just want to mention, so of course, as a disclaimer, part-time and flexible approaches, they're not appropriate for students who need a visa. So if you need a visa, there could be some challenges around getting a part-time, getting a visa under part-time, but there will be challenges. So that's something to consider. But if you have a visa, as in you're already working in the UK, or if you're already based in the UK, then the part-time or flexible options are possible. So one point on the flexible, I would say, so there are these two options, but I would focus a bit more on the flexible, because the flexible option allows you to take modules across 5 years. So you have this open, you enroll in year 1, and then of course we will support you in choosing what modules, the order of the modules, so that you can learn from the foundation to the more advanced type of modules. But the idea is that you would build the skills in 2 to 5 years, depending on your time and interest and on your availability. And you would take taught modules during these 5 years, and then the dissertation after you have completed the taught modules. And it's really building up a program based on your needs. Something that is important is, of course, we require students to attend. So as we are an in-person program, we require students to attend the program, but often we do our best to make sure that for flexible students, you don't need to be in London more than 1 day a week. So if you work outside London, you can commute to London for that day a week, and then for those during during term time in term 1 and 2. And so we can really discuss. I think it's worth, yeah, if you have my email address, I can also add my email address here on the chat. Feel free to send me an email and then we can schedule a meeting. Just put my email address. Chat. We don't see any further questions. Check Q&A. Okay, I don't see any further question. Thank you very much for attending. It's great to see many interested people, and we hope to see you in the future, to be in touch with you. Please feel free to contact me if you need any further information. If anything was unclear or you need a bit more information, yes, feel free to contact me. Or if you have any questions on the lecture, feel free to contact Rui. And thank you very much for your time, and hopefully we will meet you soon. Bye.
Thank you. Bye-bye.